Hello everyone, welcome to electric drives class. Today we are going to deal with a problem related to the stator voltage control of induction motors. So here we have the problem: a 2.8 kilowatt to 400 volt 50 hertz 4-pole machine running at a rated speed of 1370 rpm. It's a delta connected squirrel cage induction motor. It has a stator resistance of 2 ohm, rotor resistance 5 ohm, and the stator and rotor reactance are 5 ohm. Magnetizing reactance is 50 ohm, and the motor speed is controlled by stator voltage control. Now, it is also mentioned that when you are driving a fan load, it runs at a rated speed at rated voltage. Now, you have to calculate you have two sections, and you have to calculate the motor terminal voltage, line current, and torque at 1200 rpm, and you also have to find the motor speed, current, and torque for the terminal voltage of 300 volt. Okay, now first we can just find out certain parameters from the rated conditions, and then we can start the calculations for the A bit and the B bit. Okay, so first and foremost, when you are dealing with problems related to induction machine or synchronous machines, the first thing that you will do is you will be finding out the synchronous speed. So I'm going to find out the synchronous speed in RPM, 120 F by P. You can substitute the values. You will get 120 into 50 by 4, and on solving you will get it as 1500 RPM. And you can also find out the synchronous speed in terms of radians per second. It is given by 2 pi ns by 60. And if you substitute the value of 1500 over here, you will get it as 50 pi radians per second. So you have got the synchronous speed in RPM as well as in radians per second. And we can also find out the value of the slip at full load. So at full load, the slip is given by, the equation for slip is given by ns minus nr divided by ns. So you can substitute the values. This is for the full load. So ns is 1500, there is no change, and during full load your rated speed is 1370. So you can substitute 1370 over here, and on calculation you can just substitute in your calculator. You will get the value 0.0867. So you've got your slip also. Now, in the problems, you have to find out the terminal voltage, line current, torque. Okay, so the only parameter that is given is that it is running at 1200 rpm. Okay, so I'm going to find out the value of the rated torque. Okay, I'm just going to find out the value of the rated torque. We have already found out we have derived the equation for rated torque at the beginning of module 4. Okay, so I'm going to use that equation, that is 3 by omega ms into V square into Rr dash by S whole divided by Rs plus Rr dash by S square plus Xs plus Xr dash square. So you can substitute all the values over here. All the values are already provided. You have omega ms is equal to 50 pi, V is equal to 400, Rr dash is 5, S you have found out the slip, and all of the parameters here are given. I'm not going to give the value substitution over here. You can substitute it and you will get the value of torque. On substituting, you will get the value of torque as 48.13 Newton meter. You can do the substitutions and you will get this value for the rated torque. The value for rated torque will be 48.13 Newton meters. Now it is also mentioned that you are having a fan load. So for a fan load, the torque is proportional to speed square. We have already studied this in our first module of electric drives. We have already studied that for fan loads, the torque is proportional to speed square. So I'm just mentioning over here the speed as omega m square, that is the running speed. So you have the running speed over here, and this is actually the load torque, so I'll just represent it by TL. So to remove the proportionality, I'm going to substitute I have to give a constant. And you already know that omega m is actually given as omega ms into 1 minus s, and here you will be having a whole square. And you already know that for a fixed number of poles and for a fixed frequency, omega ms is a constant. So when you are removing the proportionality, you will have a constant, as well as you know that omega ms is a constant. So I'm going to include all of the constant, and I'm going to give a name k, where k is representing a constant. Whereas the slip is not a constant, because you have over here your speed is varying at certain points. Okay, so since your running speed is varying, you cannot say that the slip is constant. Even though the slip is varying, your synchronous speed is always constant. That is why it is taken into k. And here you can write it as TL is equal to k into 1 minus s whole square. Now, during the steady state condition, the load torque should be equal to the motor torque. During the steady state condition, load torque should be equal to the motor torque. So I can substitute the value of T that I've obtained over here. So I've got the value of T as 48.13, and I can substitute, instead of TL, I can substitute this value over here. So I'm just going to move to the next page. So I am going to substitute TL is equal to K into 1 minus S whole square. That is going to be equal to the rated torque value, which is given by 48.13. Now I already know the value for rated slip. So I will substitute that value of rated slip over here, that is 0.0867 square is equal to 48.13, and on substituting and solving you will get the value for the constant. Okay, so this constant is actually the value which is including the synchronous speed, as well as it is the constant which has come up when you are removing the proportionality. Okay, so you have got the value for K, and you can get a generalized equation for load torque. That will be, you substitute the value of K into this particular equation. You can substitute the value of K into this particular equation. So you will get the load torque is given by 57.7 into 1 minus S whole square. Now I'm going to move to my problem. Okay, so now I'm going to move to my problem. In my problem, they have asked to find out the motor terminal voltage, the line current, as well as the torque for a value or for a running speed of 1200 rpm. For a speed of 1200 rpm. So you can already see that when your running speed is changing, automatically your slip is going to change. So what I'm going to do is that initially, for 1200 rpm, I'm going to find out the slip. So at 1200 rpm, what will be the value of slip? S will be equal to ns minus nr divided by ns. Okay, on substituting in your calculator, you will get the value of slip as 0.2. Now, you need to find the value for terminal voltage V. You need to find out the line current or the supply current IS, and you also have to find the value of torque. Okay, so these are the three parameters that you have to find out. Right. To get the terminal voltage, you have a equation for torque over here. Okay, so I'll just explain. You have your equation for torque over here. Okay, so the equation for torque is including your voltage over here. All the parameters that are given over here are already known. But the problem is that you don't know the value of the torque. You don't have the value of torque with you. So if you get the value of torque, you can find out the terminal voltage. Or I can say that if I get the terminal voltage, I will get the torque. Okay, but it's difficult to find the terminal voltage because you don't know the value of current. Okay, so everything ultimately is interconnected. So you have to look at some other method. Okay, so you can see over here, we have already found out a generalized equation for load torque. And you can see that in this particular equation, the load torque is depending only on the slip, and the value of the slip is already known to us. Right. So I can say that again, during the steady state condition, T is equal to TL, right? So if I can find out the value of TL, I will ultimately get the value of T. If I get the value of T, I can find out the value for terminal voltage, and then correspondingly I can also find out the supply current. Okay, so this is the procedure that we are going to follow. So you have to find out the value for the load torque. And finding out the value of load torque is not difficult because you already know the equation. Load torque is equal to 57.7 into 1 minus 0.2 square. So you'll get the value of load torque. You will get it as on solving in your calculator. You will get it as 36.9 Newton meters. And you can equate this value to your equation over here. Right, so here you know all of the values except for the terminal voltage. All the values are known except for the terminal voltage. So you can do the substitutions. Okay, I'm not going to do the substitution over here. So 36.9 is equal to your equation, that is 3 by omega ms into V square into RR dash by S divided by RS plus RR dash by S square plus XS plus XR dash square. Okay, so you have to just simply note that omega ms is the same that rated value, but the slip value that you have to substitute is 0.2. Remaining all values are the same. And on solving, you will get the value of V. Okay, on solving, you will get the value of V. The value of V is going to be 253.2 volt. The value of V is going to be 253.2 volt. So you have got the value of torque, you have got the value of voltage, and the other parameter that they have asked is the line current. Okay, so the other value that they have asked is the line current. Now the line current can be found from our equivalent circuit. Okay, so the line current can be found from our equivalent circuit. So I'll just draw the equivalent circuit over here. I'll just take my next page. So you already know that the equivalent circuit is given by the stator resistance, the stator reactance, then you have, then you have the rotor reactance, and you have the rotor resistance, and then you also have the magnetizing inductance. Right. Then you also have the magnetizing inductance. Now, over here we are going to take the simplified equivalent circuit. Okay, so you are going to take the simplified equivalent circuit. So your magnetizing reactance or magnetizing inductance is going to be over here, and I'll just mark all of the parameters over here. Right, so I've marked all the parameters, and this is going to be my supply current, this is my rotor current, and here I have the magnetizing reactance. So my supply current, and this is going to be your terminal voltage V. So my supply current is actually the sum of magnetizing inductance as well as the rotor current, or you can say the stator current. Both are the same because you have used a simplified equivalent circuit. So if I can find out the value of IR, actually this is IR dash, if I can find out the value of IR dash and IM, I can find out the supply current. Now to find out the magnetizing current, you can see that the voltage V is applied directly to the magnetizing reactance. So I can say that the voltage across the reactance is V, that is equal to IM into XM. Right, that is equal to IM into XM, and since it's reactance, I'm going to include the complex term, that is J into XM. Okay, so from this I can find out IM is equal to V divided by J into XM, and you can substitute the value 253.2 divided by XM is 80 into J, and you will get the value as minus 3.165 J amperes. Similarly, you can find out IR dash. So IR dash is actually, you can see this is your IR dash. So in a similar manner, you can see that this is all of these parameters over here. You can see that all of these parameters over here, they are actually parallel to XM. So the voltage drop across all of these four elements is equal to V, or the voltage across all of these four elements is V. Okay, so from this I can say that voltage V is equal to IR dash into RS plus RR dash by S plus J into XS plus XR dash. So I just change the bracket over here, and you will get IR dash is equal to V divided by RS plus RR dash by S plus J into XS plus XR dash. On substituting and solving, you will get the value for current as 8.246 minus 3.054. You can just try and solve the values. You will get this particular, or substitute in your calculator. The voltage value is 253.2. Don't forget that. And the slip is actually 0.2. Right. And finally, to find out the supply current, you will get IS is equal to IR dash plus IM. So you have found out IM, and you have also found out IR dash, and you will get the value. I am going to write the value in polar form, that is 10.328 angle minus 37 degrees, and this many amperes are flowing. And actually we need to find out the line current. So to find out the line current, you can see that here this is an equivalent circuit diagram. So to find out the line current, what I am going to do is that to find out the line current, I am going to multiply the magnitude of the supply current over here. I am going to multiply it by √3. This is to find the line current. Okay, since it's three phase, that is why you have √3. So that is, you will get the value of 17.89 amperes. So this was your first part. Now you also have to find the answer for your B part. Now you can just read the question for the B part. Now in the B part, you can see that again you have to find out the current, you also have to find out the torque. But instead of the terminal voltage, as in the case of the previous question, you have to find out the speed. Here the terminal voltage is given and you have to find out current, torque and speed. Okay, so again we'll be following the similar procedure. Okay, but there is a problem over here. Okay, we will try to follow the similar procedure. So you can see that in the previous case we started out with the load torque. Here it is not possible to find out the slip because you do not know the speed. Okay, for your B part, you do not know the speed, that is why you cannot find out the slip. And in your equation for the normal torque, you are having slip, so again it is a problem. So we can see how we can continue with this particular problem. So we can just move to B part. Right, so we are going to move to the B part. What is the equation for load torque? Load torque is given by TL is equal to 57.7 into 1 minus S whole square. Your equation for motor torque. Your equation for motor torque is T is equal to, you know the equation, right? 3 by omega ms into V square RR dash by S whole divided by RS plus RR dash by S square plus XS plus XR dash the whole square. Right. So here the terminal voltage is given. You know the value of RR dash, omega ms, RS, but you don't know the value for slip. So you can substitute all of these values, and you also know that during steady state T is equal to TL. T is equal to TL. During steady state, T is equal to TL. So you can do the substitutions. That will be 3 by 50 pi into the value of voltage is 300 square into 5 by S divided by 2 plus 5 by S whole square plus, so that will be 5 plus 5 square. That will be equal to 57.7 into 1 minus S whole square. Okay, so now if you look at this particular equation over here, you can see that S is the only variable that is unknown. So if you can find out the value of S, so you can see S is present at 3 spots over here. You can simplify this whole equation. Okay, you can simplify this whole equation and you can find out the value of S. Okay, so on finding out the value of S, you can find out, ultimately you can find out the value for load torque, and you can get the value for current as we did in the previous case. Right. So what we are going to do is that you can do the solving and rearrangement on your own. On solving and rearranging, you will get the equation as such. Okay, so you're going to have a S raised to 4 term over here. S cube plus 89s square minus 179s plus 25 is equal to 0. So this is the equation that you're going to get once you solve this particular equation. And on solving this equation, you can solve it, those who are having the white scientific calculators, you can solve up to the power 4. Okay, so you can substitute the values and you can see that the only feasible value of s that you will be getting is 0.147. The remaining values cannot be used. It's either complex or it's negative. So the only value of s that you can use is this particular value. So on getting the value of slip, you can substitute the value of slip in the equation for load torque. So you will get 57.7 into 1 minus 0.147 square, and you will get the value for load torque. Sorry, it's actually 41.94 Newton meter. And you can find out the value for speed. NR is equal to, you are already familiar, it is NS into 1 minus S. So NS is already known, and you will get the value over here. That is 1279 RPM. You can do the substitutions. You got the value for slip, you know NS. And again, you can find out IS. So IS is equal to, again, IM plus IR dash. So that will be 300 divided by J into 80 plus, I'm just using the equation as we did in the previous case. You can see over here, we are using this equation over here and this equation over here. So that will be 300 divided by 2 plus 5 by 0.147 plus J into 5 plus 5. On solving, you will get it as 9.75 angle minus 37.3, and again to get the line current you're going to multiply it by root 3. So that will be root 3 into 9.75, and finally you're going to get the answer as 16.88 amperes. So I have tried to briefly explain this problem. For more videos you can subscribe to our channel, and you can just go through the playlist for electric drives. Thank you everyone for watching the video. Please stay tuned for more videos.